Hello everyone, welcome back to this Python lab session. So, in this session we will continue from the we will just proceed to the next lab program, that is about 7th. So, here 7th program, again it is very simple, just to addition, write a program to multiply two matrices, matrix multiplication. So, here only thing is we need to remember two matrix. So, matrix means it consists of, there is a row and column, the size of the row and column. So, you just we need two inputs are two matrix, matrix A and matrix B, and the result we want to store somewhere, right, that is your third matrix. You need to initialize that. So, that is just a simple program here. So, see, first I will explain, and then probably just we will go back to the code and we will see how exactly we can write. So, input, what is input? A matrix with the dimension m cross n, that means we know m cross n means row into column, and B again the same matrix with the dimension n into P, again both rows and columns. Process, how it works? The program first checks in what exactly it will do. First it checks if the number of columns in the matrix A, so the n, that means the number of columns in the matrix A is equal to the number of rows in the matrix B. It is very that is the reason m cross n and n cross P I have just mentioned, because first the columns in the first matrix and rows in the second matrix should match. So, that is the reason m into n, n into P, because n are same. So, number of rows in matrix B, if it is not matching, number of columns in the first matrix and number of rows in the second matrix is not common, then multiplication is not possible. That always you keep in mind whenever you are giving an input, the number of columns in the first matrix and number of rows in the second matrix should be same. So, it initializes the result matrix. So, that I already mentioned, we need one more matrix just to store the result, same m cross m P, filled with zeros. Initially always the entire that resultant matrix is initialized with 0. So, now the program then multiplies the matrices using the 3 nested loops. Why 3 nested loops? See, there will be a row, we need to matrix multiplication, we know that, right. So, row into column. So, that is outer loop always iterates over the rows of matrix A. First, why we need 3 loops? This is what we are going to specify. Outer loop iterates over the rows of matrix A, first matrix rows only. The middle loop iterates over the columns of the matrix B. First outer loop is rows of the matrix A, middle loop is columns of the matrix B, inner loop, the last inner loop performs the dot product, like the dot product of the corresponding row of A and column of B matrix, and stores in the resultant matrix. See here, and finally the program prints the output, that is the resultant matrix, whatever you have stored that will be printed here. Here I have given the example. See, A is equal to 1, 2, 3. How many columns here? 1, 2, 3. 3 columns are there, rows 1, 2, 3. See, A and B, the result. So, after this result we got this is the output, and we need to print that. See, this is the simple program, and now we will try to understand how exactly the implementation can be done. So, we will just look at the implementation point of view. See, now this is the code. We are creating a function called def matrix multiply. Here we are sending two parameters, both the parameters are matrix 1 and matrix 2, that is A, B. Get the dimension. First we will try to get the dimensions of both the matrix. Rows of A, how do you find out? Just use the function length of A. And columns, so we are just trying to use of columns. So, in that rows, so row, first row is, there is an index, right. So, A of 0, length of A0, how many elements are there in that first row? So, probably that will be, you will get the clear count of how many columns are there in the first matrix. Similarly, row B, column B. Now, we have the values row, how many rows are there in the first matrix, how many columns are there in the first matrix. Similarly, rows and columns in the second matrix. Now, can be multiplied, check whether if matrix can be multiplied or not. So, how do you check? Already I mentioned columns of matrix A should be equivalent to the rows of matrix B. So, that is the reason if column underscore A not equal to rows of matrix B, rows underscore B. If true, then you will raise an error saying that columns in A matrix must equal to the rows in B. If not, that means both are matching, then you will initialize the result matrix. What is the result matrix? We are just taking from 0, result is equal to 0 for in range of columns B. Like if I say column contains 3, it will just go and get each and every element, and for in range of rows underscore A, it is again the rows from the matrix A, and it will start multiplying. As already mentioned, what are the what are the uses of these 3 inner loops, outer loop, inner loop, and one more inner loop. All these things we have discussed. So, and now see, finally we are just we are doing all the calculation, we are returning the result. So, this is the matrix A and this is the matrix B, and finally we got the result. So, this is the result we are printing, and again the inner elements, or the elements which consist the matrix, we need to print each and every element in the matrix. That is the reason row in result, again we are applying the loop for loop and we are printing each and every element. So, it is printing. So, this is about matrix multiplication. Only thing is we need to make sure that whether the size of the column from the first matrix should be equal to the number of rows in the second matrix, then only we can multiply. Otherwise, if it is not matching, then multiplication is not possible. Always while giving the input or defining the input matrices, you just make sure that the number of columns in the first matrix should equal to the number of rows in the second matrix. If it is fine, if once you ensure that, then rest process will be this is the one. Okay, thank you.